So, hello everyone, good afternoon. We will wait for 2 more minutes. So, then we will start. So, let's start with the introduction of ourselves. So, let's start with Ravindra Bangarji. He has also raised his hand. So, Ravindra Bangar, can you please introduce yourself? Let's move to Sudarshan Veeraji.
Good afternoon, madam.
Good
I
afternoon.
am D. Veera Sudarshan. D. Veera Sudarshan, PhD scholar, madam, JNTU University, Anantapur, Andhra Pradesh.
So, you are from chemistry background?
Yes, madam. I am doing PhD in environmental chemistry, madam.
Okay, environmental chemistry only. That's good.
Environment.
So,
Your videos are helpful, madam. But more whenever you are giving answers, take more time, madam. That is the best suggestion.
okay, it means you're saying that I solved the question very fastly.
That is the only problem, madam.
Okay. Sorry for that. And thank you so much
Okay.
for your feedback. From today
Yes.
only, I will go at slower pace. Thank you so much.
Explanation is nice, madam, but little bit slow. That is size. Thank you.
Sure. So can we move to Balaji? And Sudarshan Veeraji, can you put down your hands down because you have raised your hand? Can you just unraise your hand?
Good afternoon, madam.
Good afternoon.
Myself Balaji. I did chemical engineering. Now I'm working as a process engineer in water treatment and wastewater treatment company.
Okay, thank you. Hi Amrita, can you please introduce yourself?
Hello, ma'am.
Hi.
Ma'am, I am Amrita and I have done masters in environmental sciences from Central University of Jharkhand, Ranchi.
Okay. Okay, thank you.
Thank you, ma'am.
Can we move to Ravindra? So I think Ravindra is not available. So it's really good to see that people from different backgrounds are joining NPTEL courses, and I'm really thankful for NPTEL for providing me such opportunity to interact with you all people. So thank you so much for joining. Let's start. So this week let's start with the lecture material. I'll share my screen. So the first lecture was about buffers and how to find the buffer intensity. So there was an example. So let's move. So I hope every one of you are familiar with visual mintic. So if any one of you are not familiar, just unmute yourself and just say. I think every one of you are familiar with visual mintic. And also I hope that you all know how to solve the problems related to do the titration or how to change the pH in the system.
Yes, madam.
Okay, so in visual mintic, we can change the we can see what are the changes in the concentration of the different species when there is change in pH. There are we can see that there are four options, and one of them is the titration, in which we can titrate our system with the known titrant which we are using, and we can variate the number of titration steps, I think up to 500, and we can see the change in our system. And also from here, add component in species. We can add the species and component present in our system, and we can see all these variations with respect to pH in the system. So there was a example which was solved. Here we can see the variation in the pH. Okay, let's move. So the first lecture was all about buffer and how to, and this expression is for the buffer intensity. And in the next lecture also, I think it was about buffer intensity. So buffers are those which resist the change in pH of the system, and buffers are made from the acid and base, depending upon at what pH we want the buffering to occur. If we want the buffering at around 6 or 7 pH, then we have to take the acid and base whose pKa value will be around that pH. So these are the expressions which was derived in the lecture class for buffer intensity, and I think finally this was the expression that buffer intensity is 2.303 concentration of H plus and this. And it was for the carbonate system where alpha, okay, it was in general terms alpha 1 and alpha 2. Okay, and again we can see the graph where buffer intensity is plotted against the pH, and we can see in this system the buffer intensity is very high at around 4.5, and it is around 12. So I think the system is for the carbonate system. So this is the graph for buffer intensity versus pH, and I think this is for the phosphate system, because we can see three buffer intensities are higher at one at around 2, one at around 6, little bit greater than 6, and one around 12. So first lecture number 26 and 27 was about buffer and buffer intensity. Then lecture number 28, 29 and 30 was about alkalinity and acidity. So it was discussed alkalinity is the acid neutralizing capacity of the system, and this is the expression. Basically all those species which will consume H plus will be there in the alkalinity. And next different cases were solved, and followed by lecture 29, which was also about alkalinity, and also a numerical was solved using visual mintic, followed by last lecture in which there was this there it was about acidity, Mendel acidity, phenolphthalein acidity, and total acidity. So we will see numericals based on these concepts, that is buffer intensity, acidity, and alkalinity. So I hope you all have gone through the lecture. If not, then I request you all to please go to the lecture. So So till now, if any one of you have any doubt, then you can just unmute yourself and you can ask so that we can discuss that question or concept, or otherwise we can move directly to the questions. So let's move to the first question. So here a graph is given. A solution is titrated using NOH and the change in pH is plotted against volume of NaOH used. According to the plot given below, which of the pH points have good buffering capacity? So we have been given a graph between pH and volume of the base added, and we have to find out the pH at which the system was showing high buffering capacity or good buffering capacity. So I will give you all 5 minutes. Just take your time, think about this question, and then write your answer. And please also give explanation for whatever whatever option you are giving. Also give explanation for that. So just take your time and write your options in the chat box. So one thing I forgot to mention is that there can be multiple options which can be correct. So think about that, because there are more than one option which is correct. So I got one answer, but we'll wait for 2 more minutes. Then we'll see. So others who are solving, so please try to solve and write your answer in the chat box. We'll wait for 2 more minutes. So I got two answers. One of you answered as pH 4, 8 and 12, and I would like to say that there is no pH 13 is not in the option, so it is pH 12 only. So let's see. So we can see in the system that as base is added from pH 2 to pH 4, there is around 20 ml of the NOH added, but the change is very small. It has gone from 2 to 4 only. But when we see from pH 4 to pH 8, there is only 10 ml of NOH added and there is increase in 4 units of the pH, that it goes from 4 to 8. And again, when around 20 ml of NOH or base is added, there is slightly any change in the pH. And again after that, there is a sudden increase in pH as we add around, I can say, 1 or 2 ml of the NOH, and there is sudden increase in pH and it goes to around 12. And again, there is a flat line which shows very small change in pH with increase in the NOH, that is around 15 ml, I can say. So the range, that is this one, and this one. These three are the pHs. These three are the pH where there is a very small change in the pH with increase in the with titration with base. So we can say that these three pH are the point at which this system is showing good buffering capacity. So the correct answer is at pH 4, pH 8 and pH 12. This system has good buffering capacity. So I hope this question is clear. If you have any doubt, you can just unmute yourself and ask the question. So let's move to the next question. So here is the explanation. So these slides will be provided to you. There is a section in the portal where where the link is given, and with the link a spreadsheet is open where the link for the video, that is this recording of this uh, live session along with the slides which we are using, these two links are provided for each week, so you can go and refer the videos and slides there. So let's move to question number 2. Here also a graph is given and we have been asked, there are some statement are given and we have to select which of these are correct. So the question is, two solution A and solution B are titrated by adding acid or base into the solution, and the change in pH is plotted against volume of acid or base added. Which of the following option is or are true for the graph? So there are more than one option which can be correct. So there are two solutions, solution 1 and solution 2, and we are adding acid and base. So in solution 1 there is increase in pH, so base is added, and in solution 2 base is added, and in solution 1 there is decrease in pH. So acid is added, these two solutions are titrated separately and these are plotted, and we have to find out for the reason 1, 2 and 3 which of these options are correct. So I will give you all 5 minutes for this question. Just think and write your answer in the chat box. So let's see the solution for this question. So, so the first we will go, okay, A, E and D. So I'm getting different options from different people. So three options are correct, which are A, B and D. These three are correct. Only C is the incorrect option. So let's see. So we'll start with the first option, that is at pH above 10. Solution 1 is a good buffer than solution 2. So we will see for pH 10. So this is pH 10. So for pH greater than 10, that is this region and this region. Solution 1 is a good buffer than solution 2. So we can see that we are adding this much of acid, and by adding this much of acid there is a change in the pH from 10 to 8. But we can see in solution 2 that the volume of acid or base added is smaller or less as compared to the solution 1. So we can say that at pH 10 solution 1 is a good buffer than solution 2. So this option is correct. Next one is solution 1 has good buffering capacity in region 1. So this is also correct, that in region 1 solution 1 is showing good buffering capacity because there is change in pH from 10 to 12 to 10 when this much amount of acid is added. And next option is solution 1 has good buffering capacity in region 2. No, this option is wrong because we can see that in region 2 there is sudden change in the pH when very small amount of acid is added. So there is change in pH from around 9 to pH 2 when only this very small amount, that is this amount of acid is added. So in this reason solution 1 is not a good buffer. So this option is not correct. So we'll move to the third option. Solution 1 has good buffering capacity in region 2. Sorry, this is the wrong. And last option is solution 1 has good buffering capacity in region 3. Also we can see in the region 3 there is very small change in pH when this much volume of base is added. So this option is also correct. So A, B and D, these three are the correct option, and only option C is not the correct answer. So I hope this question is clear. If you have any doubt, you can just unmute yourself and ask, and you can ask your doubt in between also. So let's move to the next question. So this is the explanation. So the question is, again it is a graph is given and we have been given some options. We have to select the correct options. So a buffer intensity versus pH graph is drawn for a multiprotic acid. Which of the following options are true for the graph shown below? So we have been given 6 options and we have been given the graph. So based on the graph, we have to find out which of the following are the correct options. So like previous questions, there are multiple options which are correct. So take your time. I'll give you around 7 minutes because there are 6 options. So just take your time, try to solve this question and write your answer in the chat box, and then we will see how to solve this question. So I got two answers and both are different. So let's see. So we will see the first option, that is option A. The graph is for diprotic acid. So we have three peaks for the buffer intensity 1, 2 and 3. So we know that any acid or base have high buffering intensity around its pKa values. So this has 3 buffering intensity peaks, so it will have 3 pKa value. So it is a triprotic acid. So option B is correct. A is not correct, rather B is correct. So the option C is pKa2 is 6.7. So the points at which the buffering intensity is high, at that corresponding pH, the acid will have its pKa value. So the first point is here. So it is somewhat around 3. The second point is around 6.5, little bit greater than 6.5 because this is the line for 6.5. So the option is pKa2 is 6.7, so it is correct. So we can see that pKa1 is around 3. pK value, second pK value is around, we can say 6.5 or 6.8, and the pK third value of pK is at 11, nearly at 11. So the option number C is correct. And the option D is pKa2 is at 9. No, at 9 there is, this graph shows there is the zero buffering capacity. So option D is not correct. Next option is number of high buffer intensity regions are 3 except for extreme pH values. So this is also correct, because we know at very high pH and at very low pH the system shows very high buffering capacity. So we can see that this peak can increase. So, and also it can increase in this side. So at very low and very high pH, the system shows good buffering intensity, and except that there are 3 points where the system is showing good buffering capacity. So option D is correct. Let's see the last option. Number of high buffer intensity regions are 2 except for extreme pH values. So this is wrong, because there are 3 regions where the system is showing good buffering. So option B, C and E, these 3 are the correct options. So let's move to the next question. So the question is, so just give me a minute. Sorry, I forgot to add animation for the solution. So the question is, if H plus is 1 millimolar and OH minus is 0.001 millimolar, bicarbonate is this much and carbonate is this much, then alkalinity is, so we have been given the concentration of the different components. We have to just put in the formula of alkalinity and find out how much is the alkalinity. So I give you all 5 minutes. Just take your time and do the calculation. So I will also provide you the options. So these four are the options. So just take your time and solve the question. So till now I haven't received any answers. So let me provide with the formula for alkalinity because I think you all don't remember the formula. So alkalinity is given as so this is the formula for alkalinity when all the species will be present in moles per liter. So just plug in the values and you will get the value of alkalinity. So I will give you all 3 more minutes to solve this question. Then we will see the solution. So I got only one answer from your side. So let's see how to solve this question. So if we take the concentration of these species in terms of moles per liter, but we can see that in the question for the carbonate it is given in terms of milli equivalent per liter. So we will have to convert it into moles per liter, or we can convert the others in milli equivalent per liter. So let's see. So for hydroxide it is 0.001 plus, let's do one thing, convert all into milli equivalent only. Bicarbonate is 0.1 plus, so if we take in terms of milli equivalent, then alkalinity is given as OH minus plus HCO3 minus plus CO3 2 minus H plus. Because for all the compounds, that is hydroxide, bicarbonate and H plus, the Z value which we take to calculate the number of equivalents is 1. So here the concentration in moles as well as in milli equivalent will be same, but for carbonate system the Z will be 2. So to convert the concentration in moles per liter to milli equivalent, we will divide by 2. So by dividing by 2 and 2 will get cancelled out, and we will get coefficient of carbonate will be 1. So if we calculate, so we have put the value of hydroxide, bicarbonate and carbonate is 0.1. So 0.1 minus H plus is 1. So after solving this, let's see what value we are getting. So I think we will get minus 0.799 milli equivalents per liter. So option C is the correct answer. So I hope this question is clear. If you have any doubt, just unmute yourself and you can ask. If you have any doubt in the conversion of the formula from moles per liter to milli equivalent per liter. So I'm not getting any answers. So I think that there is no doubt in this question. So let's move to the next question. So the question is, if carbon dioxide gas is bubbled in a solution, then which of the following option or options is or are true? So we have to find out which of these options will be true. There are more than one option which can be correct. So I will give you 5 minutes. Just take your time and write your option in the chat box. So I got two answers. Let's see which is the correct option. So C and E are the correct option. So let's see. So we are bubbling CO2 in a solution. So CO2 will from the gas phase. It will dissolve and form CO2 aqueous. And as we know, CO2 aqueous it can form H2CO3 aqueous. And H2CO3 it can either form H plus and HCO3 minus, or it can form 2H plus and CO3 2 minus. So let's number these expression 1, 2, 3 and 4. So from reaction 3 we can see that each mole of H2CO3 will give 1 mole of H plus and 1 mole of HCO3 minus, and each mole of H2CO3 can give 2 moles of H2H plus, 2 moles of H plus and 2 moles of carbonate, 1 mole of carbonate. Let's see what is the expression for alkalinity. It is given as the acid neutralizing capacity. So for a carbonate system, this is the expression. So suppose H2CO3 it dissociates in H plus and HCO3 minus. So if we can see in alkalinity that there will be addition of one bicarbonate and again there will be subtraction of H plus. So alkalinity will be same as the value before bubbling of the CO2. Again if we see that it dissociates into 2H plus and carbonate, so again it will give us 1 mole of carbonate and again 2 moles of H plus. So again these two will cancel out and again the alkalinity will be same as before. So we can see that by bubbling of carbon dioxide gas, there is no change in the alkalinity of the system. Now let's see the pH. We know pH is minus log activity of H plus. We consider the system as diluted, so it will be concentration of H plus. So with bubbling of CO2 gas, there is increase in carbonic acid and there is increase in H plus concentration because H2CO3 will dissociate and give us H plus and 2H plus. So with increase in H plus concentration, we know that pH decreases. So again our pH will decrease as H plus will increase. So option A, that is alkalinity increases, decreases, these two are not the correct option. pH increases, no, pH decreases, so option D. Okay, I think there must be one more option which says that alkalinity remains constant. Sorry for this. So I think I forgot to add this option. I'm really sorry for this. So the option which will be correct will be D and F. That pH decreases with the bubbling of CO2 gas, but there is no change in the alkalinity of the system. So let's move to the next question. So again, if CO2 gas is bubbled in a solution such that H2CO3 increases by 1 equivalent per liter in the solution, then which of the following options is or are true? So there can be more than one option which can be true. So I will give you all 5 minutes. Just think in the term that with bubbling of CO2, what changes will be there in H plus and carbonate and bicarbonate, and you can find out the answer. But here it is for acidity, so there is also changes in acidity with bubbling of CO2. I will give you all 5 minutes. Just take your time and write your answers in the chat box. So let me provide with you the formulas for total acidity and phenolphthalein acidity. So these two are the expression for total acidity and phenolphthalein acidity. So please try to solve this question. I'll give you all 2 more minutes. So let's see which of these options are correct. So we are bubbling CO2 and there is increase in H2CO3 concentration by 1 equivalent per liter. So we know that if we are bubbling CO2 gas in the solution, it will form H2CO3, which is denoted as S star. And this H2CO3 will dissociate either in H plus and bicarbonate, or it can dissociate in 2H plus and carbonate. So if there is increase in H2CO3 aqueous concentration by 1 equivalent per liter, then we can see from, let's number this as 1, 2 and 3. So from reaction 2 we can see that with increase in 1 equivalent per liter of H2CO3, there is increase in 1 equivalent of H plus and 1 equivalent per liter of bicarbonate. So if we plug it in total alkalinity, it will increase by 1 and it will increase by 1. So there is total increase by 2 units. Because carbonate has nothing to do with the total acidity, so it will not affect the total acidity, but it will affect the phenolphthalein acidity. So we can see that from equation 3 that 1H2CO3 is dissociated in 2H plus. So and again there is one carbonate, but it is in minus sign, so -1. So overall increase will be by 1 unit. So our total alkalinity will increase by 2 units, and our phenolphthalein acidity will increase by 1 unit, or I would say 1 equivalent per liter. So the first option is total acidity increases by 1 equivalent per liter. No, it increases by 2 equivalent per liter. So option B is the correct option. Next is phenolphthalein acidity increases by 1 equivalent per liter. Yes, this is correct. Obviously, the next option D, that is phenolphthalein acidity increases by 2 equivalent per liter, is not correct. And the last option is H plus increases by 2 equivalent per liter. So we can see that there is increase in H plus. So H2CO3 will dissociate in 2H plus and carbonate. So there is increase in H plus by 2 equivalent. So E is also the correct option. So B, C and E, these three are the correct options. So let's move to the next question. So this is the overall explanation. You can go through this from the slides. So question number 7 and 8 are numerical based question. So here it is given that H2CO3 is 0.1 molars is added into a solution. The system is closed. The alkalinity of the solution after the equilibrium is achieved is, and we have to find out the equilibrium. So the conventional way is to find out first the pH of the system. We do the charge balance, we do the mass balance of the component, then we do the charge balance and find out the pH and find out the alpha 1, alpha 2, alpha 3, which will give us the concentration of all the three species of H2CO3. And then by knowing the pH we can find out the hydroxide and H plus concentration, and then put everything in the alkalinity equation. But we are using visual mintic, so we will first find out the pH of the system, because we are adding H2CO3 as 0.1 m. So this will dissociate and give us total, because one H2CO3 will give us 2H plus, so H total will be 2 times of 0.1, that will be 0.2 m, and CO carbonate total will be 0.1 m. So we can find out the pH of this system by putting these two components value in the visual mintic, and then from the mintic the concentration of the different species will be given for a particular pH. So we will take out the concentration of the species and then put out the alkalinity formula and find out the alkalinity of the system. So I think we should directly move to the visual mintic and let's see, because if you all must I don't know if you all are working in laptop or not, because visual mintic is only supported in Windows. So let's start solving. This is the first page for the visual mintic. Here from we will do the calculation for pH by using mass balance. Ionic strength we will set to be calculated. From here we will add the components and the corresponding total concentration. So first change the concentration unit. I'm sorry I have not shared that screen. So let's first do that. So this is the visual mintic. We will do the pH calculation from mass balance. So let's first change the concentration to molar. Now we will add the components from here. So we were having H plus as 0.2. So we can simply type H. Here we will get H plus. It is 0.2. We will add to the list. Next it was carbonate. So let's type CO. So it will give carbonate. It was 0.1 molars. We will add to the list. We will review the list. So sorry, I have added it before. So we have added H plus as 0.2 and carbonate as 0.1. This is the components which we have added. We will go back and we will run the Mintech. So this is the pH which we are getting, that is 3.676. And we can see that here is a table which shows the different species and what is the concentration of all those species. So what we can do, we can directly print this table to Excel from here, print to Excel. So overall it is printed in the Excel. So we know that alkalinity, it is given as concentration of OH minus plus concentration of bicarbonate plus 2 times concentration of carbonate minus concentration of H plus. So let's put out everything. It is OH minus plus HCO3 minus plus 2, sorry, plus 2 into carbonate minus H plus. So this is the overall alkalinity, that is 1.48 into 10 raised per minus 10. Let's see what we have here. So option B is the correct option, but it was 1.487 and we are getting 1.4868, that is 1.487 only. So option B will be the correct option, which will give us the alkalinity in terms of equivalents per liter. So these are the pictures which I have taken from the visual Mintek and I have added here. So we got the pH as 3.676 and then we have calculated the alkalinity from here, and it was 1.487 into 10 raised per minus 10. So let's move to the next question. Just wait for 2 minutes. So this is the last question where we have been given H2CO3 is 0.1 molars is added into a solution, and then it is kept in a room having gas CO2 and H2S. If the partial pressure of CO2 is this and partial pressure of H2S is this, then what is the alkalinity of the solution after the equilibrium is achieved? So this question we will also solve from Visual Mintek. So here we can see that we are adding H2CO3 as 0.1 molars. So the total H plus concentration will be 0.2 m and total carbonate will be 0.1 m. So again we will solve this question using Visual Mintek. So I have already solved this question. Let's see. So from visual mintic, we will add the H plus, that is 0.2 m, and carbonate, that is 0.1 m in the system. Then again we will have to add the gases. So let me solve directly in visual mintic only. So suppose we have already added the components. H plus is 0.2 and carbonate is 0.1. What we will do, we have to add gases. We will go to gases, specify F1. So let's choose a gas among the gases. So first we have to choose CO2. Here it is CO2. And the pressure is given in question as, it is 0.02, I guess. Sorry. It is 10 raised to minus 2 atm, that is 0.01 atm. We will add it. It has been added. We can also add H2S from here. And H2S is 10 raised to minus 4, that will be 2 more zeros. We will add in the system. We can see from list of fixed species. So log of partial pressure is minus 2 and minus 4. We will go back and we will run the mintic. So here we can see that the pH is 4.910 and we have got the concentration of all the species. We can directly print to Excel. So it is printed to Excel and we can do the calculation for alkalinity here. So let's see, I have done that. So we have added the gases. These two are the gases which we have added. So here finally the pH will be 4.910. We will print that to Excel and we can find the alkalinity using this formula. Because there is also H2S, so we will take all those species which will consume H plus, because alkalinity is the acid neutralizing capacity. So all those species which will consume H plus will be there in the alkalinity equation. So we have hydroxide, bicarbonate, carbonate, H plus is minus, subtracted because it will not consume any H plus, and HS minus because we have added H2S. So H2S will dissociate in H plus and HS minus, and again it can also dissociate in 2H plus and S2 minus. So we will take 2 because the charge is here 2. So we will put everything in this, we will put the concentration of all these in the formula and we will get the alkalinity as 6.19 into 10 raised to minus 10. So let's see which is the correct option. 6.19. So second option, that is B, is the correct option. So these were the questions based on the previous year assignment question. So if you have any doubt, then you can ask. So or otherwise we can end the session here. So if you guys have any doubt, you can ask, or otherwise we can end. Okay, I guess there is no doubt. So thank you so much for joining, and I request you all to please join on every Sunday. So there we will discuss the previous year assignment questions, which will help you in solving the current assignment questions and also in the final examination, which is in October, I guess. So thank you so much for joining. Have a nice day.
Thank you.